Hello, my dear viewers. I am coming before you with the fourth part of our class 12th physics chapter. Now, earlier chapters I have taught you about the charges, their properties, their characteristics, about the Coulomb's law, which is dealing with the force. Next, fourth part, in a systemic manner, I will try to introduce this problem of electric field. In the earlier class, I have taught you about the electric field intensity. By short, it is called electric field. So you just be with me, very consciously be attending this, what all I'm saying. We will be going through a problem which is related to the electrical field and a logical problem which is about question, and then electric dipole I will introduce what is it, and then an electric field due to a dipole at a point on the axial line. That means due to a dipole, no, there is an electric field, and that electric field due to that dipole at a point in the axial. Axial means this axis. No, this is the negative charge, this is the positive charge. It has an axis around which it is symmetrical. No, so at that axial position, along when it is extended, no, there is a point, and at that point, what will be the electric field intensity? That is, we want to find out. So, can we continue? The thing is, first of all, the board question is asked, find the electric field at O in the square of side R. Okay, you want to find the electric field at O. Okay, this is the square. Okay, side R. Find the electric field at O. There's given two figures. Okay, first figure is A and second figure is B. So in the first figure, no, positive charges or equal charges, whether it can be negative or positive, if these charges, equal charges, are at the corners of a square. Okay, but earlier I have taught you that inside a hollow metallic conductor sphere, no, if it is charged, inside that there will be no flux lines. No, look at this. This is also familiarizing that these are all equal charges, and inside that, where there will be any field lines? No. But we want to answer in another way also. The thing is that if a flux line we draw now, it is about repelling these. This will repel this will repel this will repel this. So the flux lines will be somewhat like this way. Okay, here also the same, this way. So this area now will be unaffected. So in the answer key, it is given in the figure A, the net electric field at O is 0 due to the same type of charges at the corners. If the same type of charges at the corners, no, they all repel against each other. So the field lines will they will repel just from that arising perpendicularly, and then not it is repelling against this. So it will not go to the O position. Okay. If it is attractive, then it will reach over here. But if it is the same charges, no, that field lines will not enter this O. So the electric field at O is 0. And you can find out the next question. A charge is over here. Answer the electric field E at a point O, which is due to the charge. Hey, consider earlier in this classes I have told you, that a intensity, electric field intensity due to a point charge. Consider that point charge be at O. Okay, that's the answer key. So at O, no, we are taking a unit charge at that position. So the point of reference charge is Q. Okay, then how do we find out this distance from O to Q? Then we already know that this is a square. So this is 90 degree. This is R, and this will be also the same side R. So R square plus R square is equal to 2R square. That is this diagonal distance. But we only need half now. So calculating diagonal distance is equal to R square plus R square is equal to D square, diagonal distance square, is equal to D square is equal to 2R square. then d is equal to root of 2r square. That means root 2r. That is the diagonal distance. But we only need half of that diagonal distance now. So d by 2 is equal to root 2r by 2. Okay. So, but 2 can be written as root 2 into root 2. Okay. Root 2 into root 2. So, that root 2 on the top and the root 2 on the bottom get cancelled out. Okay. So what will be left? R by root 2. That R by root 2 is this distance, that is d by 2, which is written over here. So the distance between the point charge and the reference charge is R by root 2. Okay. So that means R by root 2 the whole square by the equation. Okay. So by simplifying all this now, you know earlier electric field density is equal to 1 by 4 pi epsilon 0 q by r square. So we got R, the distance between the reference and the point charge, and here now just r square by 2 we will get. Okay, that 2 will go get to the numerator because you know q by 1 divided by r by 2, q by 1 divided by r square by 2 is equal to q by 1 into 2 by r square. That is q into 2, that is 2q. 2q by r square. This is the final answer. Okay, that's it. And then comes our board examination question. This is a logical question which is asked. An electron and a proton fall through a distance in a uniform electric field. That means an electron, negatively charged, a positively charged proton fall through a distance, same distance in a uniform electric field. That means the field is uniform. Equal field is there all over the distance. Okay, due to any reference charge. So compare the time of fall. That means we want to compare this thing which will reach earlier, which will complete that distance earlier. That means, so when we take the positive charge and negative charge now, they are equal. Positive and negative, their magnitude are equal. So by electrostatically, the force is same for both. But no, we want to consider a small difference in mass now. That is, this electron mass is very much low than this proton mass. Look at this, 10 raised to minus 27. That is having a higher value. But sometimes 1,000 times greater is nearly 1,000 times greater is this, lesser is this electronic mass. Electronic mass is nearly 1,000 times lesser than protonic mass. So although electrostatic forces of the both are same, but the mass of electron is less. So the electron takes a lesser time to complete the distance. Okay, this is the logical answer. Then comes a concept of electric dipole. Electric dipole, first of all, you want to understand di, that means two poles, that is positive and negative. These two poles are separated by a distance 2a. So remember the distance to be only 2a. This is a convention. Please try to understand if it is a problem arising in the mathematical problems. No, you just use a formula of electric dipole to be q into, that means take one charge, whether it is positive or negative, it doesn't matter. Take a charge, q into two-way distance. So the dipole moment we want to calculate is equal to magnitude of either of the charge into length of the dipole. That's it. So altogether, I am first of all I told about dipole moment, but this, what is an electric dipole? The dipole is two equal and opposite charges, plus and negative, separated by a small distance 2a. That's a dipole. And total charge, that means a plus and a minus equal charges. Now that will cancel out. So total charge is equal to 0. But electric field is not equal to 0. You know, because this has a field. This also has a field of its own. So these two fields are separated by a distance, small distance. So electric field is not equal to 0. It has a certain amount of electric field by the magnitude of charges which they have. Okay, which are used to form the dipole. And the dipole moment I have said earlier, that means the dipole moment which is represented by P and arrow, that is a vector symbol, is equal to Q into 2a. Q is any of the charges and the distance between these two charges. Okay, P is the arrow representing the vector, P and an arrow representing the vector is equal to magnitude of either charge, that is Q into length of the dipole 2a. Q into 2a. Okay. You can study also 2a into Q or Q into 2a. Anyway, just understand any of the charge into the distance. Then comes the direction of dipole. Okay, if a lines of force from the charge, it will the field lines when it emerges from plus q and converges in minus q, then the opposite direction is of dipole. The direction of dipole is from negative to positive q. This negative to positive q. That is the direction of dipole. Just remember that dipole direction is opposite of the field direction. Okay, that's it. Electric field lines direction. Direction of dipole is opposite of electric field lines direction. So unit of this dipole is, we have a charge, so it goes for coulomb. We have a distance, though it form, that's the cause of this meter. So coulomb meter, that is coulomb meter. That's the unit of dipole. And then comes the electric field due to a dipole at a point in the axial line. Okay, we have two charges. The total charge is plus and minus will get cancelled out, but there is an electric field due to this and this, no. So we want to find out the electric field due to a dipole. There is a field due to this dipole on the axial line. Consider this to be a big sphere. Then there is an axis passing through this, and then it is passing through this. This is extended towards a point P. So this is the points where there is said to be axial line. In the axial line, we prefer a point P, and we want to find an electric field density at that P point due to this dipole in the axial line. Okay, so by this diagram I will mention what are all the variables which are involved. First of all, there is a minus q. We first of all take the dipole direction should be from negative to positive, no? So negative q, then goes the positive q. Okay, and the distance between them is 2a, and there is a middle point here. So this point will divide this 2a into two parts, that is a and a. Okay, and then comes the axial point P, and that P, that distance from the P to this middle point of the dipole is named as R. Okay, and what will be left for the completion? This A, the same as A, here. This distance is A. Okay, so we can start. Consider an electric dipole of charge q, okay, a charge q, positive and negative, and a length 2a, which is separation distance, and let P is a point on its axial line. P is a point on its axial line, and a distance r. Okay, it's at a distance r from the middle, and distance r from the center of the dipole. From the center of the dipole, there is a distance r to the P. Okay, so intensity of electric field at P due to plus Q. We have a plus Q charge. Okay, we know that intensity due to a point charge, we know that charge Q by the distance between them. Distance between them, no, we want to find out this distance, no, Q to P, this distance. So the total distance is R, no. Then minus this distance, a distance will give this. Total distance minus this distance, that is r minus a, is that distance between this. Okay, r minus a is the distance. So we get the intensity of electric field at P due to plus Q charge, that is E1 plus Q charge, is equal to 1 by 4 pi epsilon 0 into Q by r minus a the whole square. That is along A and P. Okay, this is along this direction. And the intensity of electric field at P, that intensity at P, due to minus charge we want to find out. So the distance becomes how? You earlier know, this is A from the middle portion to this is A, then this will be A, and plus R now. So here intensity of electric field at P due to this minus Q is equal to E2 is equal to 1 by 4 pi epsilon 0 into Q by this R plus this distance A the whole square along PB. Okay, it along PB, it in another direction. Okay, along this direction. Okay, along another direction. So along the opposite direction here. Okay, so this resultant intensity of electric field is this minus the first, which is due to the positive charge, no, minus this opposite direction, no, E2. Okay, that means let it be subtracted from each other. Okay, that means resultant intensity of electric field at P due to the dipole is equal to, resultant means E. We will name it E. Then this first minus, that means due to the point charge plus Q minus due to the point charge minus Q. Just you substitute over here. Okay, this E1 just substituted over here and minus E2 is this. Okay, then we want to simplify all this. The simplification, next, we will take what are all common in these things. What are all common in these things? That means this Q by 4 pi epsilon 0 is common. And then what will be remaining? 1 by r minus a the whole square is remaining. Okay, minus from here now 1 by 4 pi epsilon 0 q by that is taken, and what will be left? 1 by r plus a the whole square will be left. Look at this thing. This let it remain there. But we want to solve all these things to a very simple form now. So q by 4 by epsilon 0 into this r plus a, how will it, we want to make the denominator same now. So first of all, by the mathematical operation, just here now multiply r plus a the whole square in the numerator and denominator. So we will get r plus a the whole square here and r minus a the whole square into r plus a square here. So by solving here, we want to multiply this r minus a the whole square top and bottom. Okay, then numerator and denominator. So we will get r plus a the whole square here. That is it. And minus r minus a the whole square here. And the denominator is same now. So r minus a the whole square into r plus a the whole square. This is the processing. Okay. Then comes we want to expand this thing here. So r plus a the whole square is equal to r square plus 2ar plus a square. That's the expansion of this. Okay. Minus a minus b the whole square expansion. That is minus r square minus 2ar plus a square. That is expansion. Then here now for convenience we will take this r minus a, I will write 2 times. R minus a into r minus a is r minus a the whole square. R plus a into r plus a is r plus a the whole square. Let it be. But here we already know a law that a plus b into a minus b is equal to a square minus b square. Now, so after all, later we want to find in this form. So from earlier steps now, q by 4 by epsilon 0 is there. When we expanded, it is there, r square plus 2ar plus a square. This minus is here. No, minus into r square minus r square, minus into minus 2ar plus 2ar, minus into plus a square minus a square. So here a square get cancelled out, r square minus r square get cancelled out, 2ar will remain. Okay, plus 2ar plus 2ar, 4ar. Okay, and denominator r plus a into r minus a. I will take a r plus a here and this r minus a. I will take a r plus a and this r minus a. So it is ordered in like this manner. So r plus a into r minus a is r square minus a square. That is a plus b into a minus b is a square minus b square. Like. So two things are there. R square minus a square 2 times. So r square minus a square the whole square. That's the equation. So, but we want to rearrange this also. So I will write this 4ar into 2 into 2ar. Okay, 2 into 2ar. That is. So E is equal to q by 4 by epsilon 0, 2 into 2ar. That means we are already, I have taught you 2a into q. 2a into q is this dipole. So I will represent a p over here. And what will be left? 2r is left. So 2r, and inside we will get a dipole. So remember this formula, 1 by 4 pi epsilon 0, 2 dipole r. Okay, by dipole moment r by r square minus a square the whole square. Along this axial line parallel to the dipole moment. Parallel to the dipole moment, along the axial line, this is the electric field intensity along the axial line. Okay, So E is equal to 1 by 4 pi epsilon 0 2 into P vector into R by R square minus A square the whole square. And we want to find out a special case also. Just consider this dipole moment. The dipole now is the length between these two poles are very small. So this will get negligibly small now. There will arise an insignificance. This A now will get reduced so much, it will be near to a zero value. So just to put that zero value over here, then I will E is equal to 1 by 4 pi epsilon 0 2p into R by R square minus 0 square. So let it go away. 0 square. We do not need it. Then R square raised to square is R raised to 4 now. So I will write 1 by 4 pi epsilon 0 2p into R by R raised to 4. This R raised to 4 and R get cancelled out and R cube will remain in the denominator. So that is a special case equation. E is equal to 1 by 4 pi epsilon 0 into 2p by R cube. That means if this distance between this dipole is very small with respect to the distance of that point taken in the axial line, then that means dipole length is very small compared to the distance taken. Then this is the special case equation, that is E is equal to 1 by 4 pi epsilon 0 into 2p by R square. Okay, my dear viewers, even if I put a very good content also, without the support, it is very difficult for my channel's survival. So please like, share, and subscribe my channel. Be with me. I'll be with you with the very frequently asked questions, very important questions from the board examinations, competitive examinations, entrance examinations. Only the time constraint matters. So I will be with you. If any doubts arise, call me. Let your parents get also acquainted with what role I am giving you the details about the studies. So be cool, be happy. I'll be with you in the next part 5.